How's it going? Is everyone enjoying Jfokus? Yes. Excellent, excellent. So I, with a friend of mine, run a little training company called Iterator Learning. That's Iterator without the O in the Iterator. And I'm here to talk to you, give a talk called Polishing the Diamond, which is basically about all the little improvements in Java 9 that aren't project Jigsaw / modularity related. I thought I'd just kick off by having a quick show of hands. So who at the moment's running Java 7 or below on most of their production systems? A few people? OK. Who's running Java 8? Good work. Awesome. Now, who's jumped on the release train for Java 9? A few people? OK. Who's planning on jumping on the release train with either 9 or 10 within the next year? OK, so that's a reasonable number. Great, fantastic. Just my own personal interest rather more than anything else. So what's really in Java 9? Well, the first thing is that there's not just library enhancements or language enhancements. There's also a nice little tooling enhancement called JShell. Now, JShell is a read, eval, print loop, or a REPL, as people like to say, which basically means it's like a little not an interpreter as such, because it's still running on a JVM, but it lets you run an arbitrary blob of Java code. So, for example, I could take 1 + 2, and the result's 3. Shocking, shocking, I know. Or it doesn't just have to be expressions. You can also run statements. So, for example, I can say print out hello world. OK? And I can also conveniently run functions within this REPL as well. So toc prints out the table of contents for the rest of this talk. So what am I going to see? What are you going to see for the rest of this talk? We're going to talk about a few improvements to collections in the form of collection factory methods. Then I'm going to talk about some improvements to the Streams API coming up in Java 9, when you might want to see and use those things. I'm going to talk about improvements to the collectors API, the optional API, and then we're going to draw a few conclusions. So none of these individual changes are necessarily huge world-changing features. And I think probably as we move to this more like this every 6 months release cycle, it's less, here's a big bang that's going to change your life, and more, here's a few things which are quite nice that add up to generally an improved programming experience with Java. OK? So if you go to most developers, or I'll ask everyone in the room, if I ask you what's the biggest problem with Java, what would you say? The biggest problem is Java. What, anyone else? Class path, OK. Anything else? Memory. OK, what I was really hoping for was you would say, it's really verbose. That's what people normally say when I ask that. So what do I mean by that? I mean, let's suppose we just want to have a list with a few words in. And I'm going to just say, hello, world, from, oh man, I wish I could type faster, Java. OK. So I just wanted to initialize that list. And in order to do that, it took me basically 5 lines of code here. It took me 1 line to initialize the list, and 1 for every single element. And it's kind of a little bit annoying when you write Java code very regularly to have this kind of verbosity overhead. But I know what you might be saying. Richard, in Java 5, I think it was, there was a nice little method called arrays as list. I'm going to write less strings this time. That said, hello world. Oh. Arrays as list. So that gave us a nice list initialization syntax. OK? But this is a bit of an interesting class that's returned. So if I take that words class and I say words object and I say get me the class that's created, it's an array list, but it's not a regular Java array list, right? It's a arrays $array list. So it's like it's an inner class within the arrays class that's kind of hidden. And what are the characteristics of this object that we get back? Well, let's try and add an element to it. So let's try and add PHP. Excellent, excellent. It stopped us from adding PHP into our list, keeping your code safe and secure in production. All right, let's try and do a few other things. So let's say, set the first element to be PHP. PHP world. It's a nightmare. It's a nightmare scenario. So it's a bit of a weird class, this one, isn't it? It's not immutable, but it's also not changeable in the same way that other Java classes are. Like, say, an ArrayList is just regularly mutative. You can add elements, you can remove elements, you can increase or reduce its size, do all sorts of things. With this thing that you get back from arrays.asList, you can set elements, you can change the elements, but you can't grow or shrink it. It's a view around a mutable array, really. OK. Now, what does Java 9 offer us? Well, Java 9 offers us these nice little collection factory methods. OK? So you get an interface like list.of. You get an interface like list, and there's a static method on it called of that will initialize you an immutable implementation of that list object. So if I try and add PHP to this list, fails. Yes. If I try and set the first element to be PHP, it also fails. Brilliant. So these collection factory methods are returning us genuinely immutable little collections, which is very, very useful. Now, one question you might be asking yourself is, why did Java not go down the route that other programming languages did, which is, say, to add in some syntactic sugar, like something like Python would let you, say, have square brackets for a list initialization syntax. And if we try and run this, we can see illegal start of expression. We can't have that syntactic sugar. And the answer here is there's kind of an interesting set of trade-offs around this kind of stuff. Making programming language changes when you've got as big an ecosystem as the Java ecosystem is a really expensive, really time-consuming thing. Whereas adding a few collections factory methods gives you most of the benefit, but with a much less engineering cost. Now, the collections factory methods aren't just for lists. I could have a set of string elements, and I could initialize a set as well. OK, let me run that again there. And that gives us a set object. Again, it's immutable. I can't add in my dirty PHP word. And again, follows a similar kind of contract there to the list.of method. There's a little bit more of an interesting case when it comes to, say, maps. Now, what I'm going to do is have a map here from string onto integer of some cities. So I want a map.of, and I'm going to have a couple of cities and their population sizes. So Brussels has 1.139 million people in, where my friend Raoul, who I run training courses with, comes from. And I was born in Cardiff, which is a bit smaller, 341,000 people. And that's initialized a map there from those key value pairs. Now, if you look at the Java doc for map.of, you'll see there's lots and lots of map.ofs, overloaded loads and loads of times. And that's because you have a lot of very specific key value pair overloads for up to 10 key and value pairs. Now, there's not a map.of varargs version for that factory method, which will just take an arbitrary number of elements as parameters. And the reason for that is that you can't have, you can't express in the Java type system something like, here's a varargs, and I want alternating parameters to be a string, then an int, then a string, then an int, and characteristics like that. They all have to be the same type if you have a varargs element. And if you have a varargs parameter, you can only have one of them. But what there is a map.ofEntries method that's been added. So let's go back here and get this ofEntries method. And there's also a static factory method called entry that I've imported here from the map interface that will let us create an entry from a pair of values. So each of those entries is an implementation, an immutable implementation of the map.entry interface that's used for representing the key value pairs in maps. And we can have a var args of those because they're one consistent type for all of them. So if you want to have a map.entry, if you want to have a map built with a variable number of elements for these collection literals, collection factory methods, then that's your solution for doing that. OK? Awesome. So the first step was cutting down the verbosity a little bit with collection factory methods. What else are we going to look at? Well, streams were introduced in Java 8. A lot of you guys and girls said you were running Java 8 or later in production, yes? What is your feeling on the streams API? Yes. Some positive people, some people just quiet. I'm going to take all the people quiet as inwardly saying yes, but just quietly. So it's a really good API, but there's a few corner cases where it can be a little bit fiddly to use or not very idiomatic to get things going. So let's suppose we take a scenario here where we want to write some code, and the user is going to set some properties, command line properties, to override where we're going to put, say, a little home directory for an application to store some config files in. So we want to say, if they give us a command line property called app home, we'll use that as our config store. Otherwise, we'll just use the user's home directory. OK? So I've not set the app home property here, so I'm going to cover stream with a couple of properties in, app home and user.home. And what I want to do is I want to look up each of those properties in turn. And if there's a property there, I'm going to put a value into the stream. And if not, I won't. OK. So perhaps the best way of doing this with the Java 8 API is if I take the name of that property, and then I flat map it a little bit. So I'm going to look up the value from that name using system.getProperty. Then if system.getProperty doesn't have a property set for it, it's going to return null to me. So I'm going to say, look, if the value is null, return me an empty stream. Otherwise, return me a stream with just that value in. And then I'm just going to call the find first method at the end of this operation. And what that will do is return me the first element in that stream. So here, I've not set the app home property, so I'm just going to get my user's home directory, which is /home_Richard. OK. That's all right. That works with streams. But put your hands up if you really, really love this code. OK. What about if you really hate it? Wow. OK. I was hoping for only a little bit of hate. That's quite a lot of hate. What about if you're kind of in the middle? This is like OK, but not really what I really want to write. OK, some people as well. Nearly as many for hate. All right. So we can do a little bit better than that with Java 9. Because in Java 9, there was a stream.ofNullable method that was added. So it takes a value. If the value is null, it returns you the empty stream. Otherwise, it returns you a stream with that value in it, which is the same pattern as we have here in the middle of the flat map. So we can just rewrite this code in Java 9. And I'm just going to say, take a flat map, take the name, call my stream.ofNullable, and look up the property from the name of the property. Boom, boom, boom. And then find first at the end. And I get the same result. OK? Much cleaner, much more to the point. Who's a fan of this code or prefers it to the other one? Excellent, excellent. Excellent. What else do we have in Java 9? Take while and drop while. OK. So I've got a list of payments here. And each of those payments has a value associated. So some money, always important when we're dealing with money to try and get code that works, right? And we've got these payments. And these payments are all sorted by value. So the first one's 900. The second one's 700, blah, 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 as we decrease in size. So suppose I want to take these payments, and I'm only interested in the really expensive payments that I'm looking at. I just want to focus on what's the most expensive things. So stream those values, filter each payment, so get its value, and let's say check it's over 500, and then collect that into a list at the end. And I need to have a couple of brackets there. OK, so let's just show that code. OK, that's cool. So that worked. It got me 900, and it got me 700. But it's an interesting thing the way this filter operation works, because I had all those values in order. They were decreasing by numeric value. But that filter operation, because the way filter is defined to work, has to apply its filtering predicate to every single element that it encounters in the stream. Now, if you only got 10 elements in the stream here, it's not really the end of the world. But what if we had 1 million? Or what if the source of that stream was something that was expensive, like maybe it was reading them out of a file, and once we got what we needed, we wanted to just stop at that point in time? There's no way with the existing Java Streams API from Java 8 in order to represent that kind of criteria. So take while is a little bit more interesting. Take while also takes a predicate and starts applying it to the first few elements in the stream. But once you get an element that returns false, it'll just stop there. And it'll stop pulling elements in through the Streams API. So if you've got a sequence of values that's ordered, and you know you're going to stop filtering partway through, this is a great way to stop the overhead of having to apply your stream operations further down the line. If you've got a source that's more expensive, like reading out of a file or something, even better, even stronger. Take while is potentially also useful in other scenarios. Like there's no way before take while to have, say, a stream that was just running, a non-terminating stream computation that was just running, even though you have infinite streams, that you could stop from another thread, or you could stop when you close the program down. Whereas now you can do something like have a take while operation that's checking a flag that's, say, an atomic Boolean or a volatile field, and then you can stop your stream computation using that. Obviously, when you've got a take while operation, which gives you the head of the list and stops at that point, you need to have its kind of dual. So an operation that applies this predicate throws away those elements and just returns you the tail of the list once the stream started turning false. So that's drop while. So drop while with our predicate for the value checking it was over 500, threw away the opening elements, and then the things afterwards that were the back end of the list. It didn't have to apply the predicate to all those elements. We were ordered here. We could just use that ordering as well. OK? So another one of the streams features that was added in Java 8 was stream.iterate. OK? So if you're not familiar with stream.iterate, it's a way of saying, hey, look, start at a value, like 0, and we're going to add 2 every time. And that's going to give me a sequence of numbers, a conceptually infinite sequence of numbers, which applies this function to get the next element. So it starts at 0, adds 2, gives me 2, adds 2 again, that gives me 4, and we'll carry on going until the end of time, or in this case, until I press Control-C. So if I just run that for a bit and then stop it, we can see it's added 2 all the way up to 17,000, whatever. That's all right, Richard, but most developers, I don't know about you guys, but most developers don't really like code that's basically an infinite loop. No? It's not usually a good idea to have that in your application software stack. So in practice, you want to have a way of controlling the number of elements that go through streams. So an obvious way of doing that is, say, adding a limit statement. So limit says, look, once you've got this number of elements, just stop. We're adding 2 every time. We're limiting at 10, so we get 2, 4, 6, 8, all the way up to 18. Nice and simple. Works very well if you want to limit based upon the number of elements you've seen in the stream pipeline. Works really well, not at all, if you want to do a limit operation based upon the value that you're encountering at that point in time. All right, Richard. What about filter? That will throw away elements we want. OK, so let's filter these numbers and say, ensure we only see things which are less than 10. OK. Well, we got the numbers 0, 2, 4, 6, 8. And before I touched my keyboard there was a pause, right? The screen was black, but my flashing cursor and the thing that says JShell hadn't reappeared. And that's because filter will blindly apply this filtering operation to everything that you see in a stream sequence. So if you have an infinite stream generator like stream.iterate, and then do a filter, even though all the numbers are going to be above 10, it'll carry on running these things. Now, strictly speaking, they aren't always above 10, because if I left that running for long enough, it would actually overflow the integers, go negative, and start being below 10 and start being printed out. But you probably didn't want that behavior either. Now, as we said earlier, we had a new operation. What was the operation we just talked about? Come on, a bit louder. Take while, exactly. So we can run the take while operation here, and because it stops the stream at that point, we stop when the number flips above 10. So that's an improvement. We don't have this computation lying around in the background doing nothing for us. But actually, there's also an overload of stream.iterate that takes a predicate here as well. So we can say, look, take the stream and stop when below 10. And that also achieves the same effect. So that's a really nice addition to stream.iterate that will stop us when below 10. All right. So we talked about streams. People on Java 8 or above. What do you think about collectors? Much more muted? OK. Collectors, thumbs up? Collectors, thumbs down? Only a couple of thumbs down. OK, mostly positive about collectors. There's a couple of additions to the collectors API in Java 9 as well. So I've got some expenses or payments. Are they payments? What's that variable called? Purchases. Sorry about that. Mind went blank. Purchases. So I've got a series of purchases here, and I'm going to let you in on a little secret. These are my purchases, my personal purchases, my utility expenses. So 2016, I spent £500 on food and entertainment. All right. I had a huge utility bill. I think I left the heating on all winter. And in 2015, I only had one expense, which was travel and entertainment. So 2015, really good year. 2016, much more boring. OK, so suppose we have these purchases, and we're going to use them for a basic stream API operation, or a basic collector API operation. What I could do, for example, is I can stream those values, and then I could immediately collect and use the grouping by collector. To say, map each expense onto the year which it's associated with. And we'll just start there, a nice and simple collect operation. So this gives me a map back. And the keys of the map are the years. And the values are lists of expenses. So here are the ones for 2016. And here is the 2015 expenses. OK. But suppose times are tough, Brexit and all that. I need to cut down on my expenses, and I need to figure out what are the big expenses that I've got to look at that I want to cut down on. So what I can do is apply the same kind of operation that we've seen earlier. I could say filter that expense, say get the amount associated with the expense, and check it's over, say, £1,000. All right. Now that works. It's removed the expenses which were below £1,000 from my bills. What it's telling me is I'm spending too much money on utility bills. I need to get a more efficient boiler. But is there something else that you can see here that was a bit different from before? It's not just removed the expense values themselves. It's also removed the whole of 2015. Now, 2015 was a really good year. I had loads of travel and entertainment expenses that year, so it must have been fun. I don't want it to remove 2015 from my past. Don't worry. The Java Streams API is good, but it's not that powerful. It can't remove a whole calendar year. What it's done here is we've filtered the values out before we collected them. And as a result, the grouping by collector never saw 2015 as an input thing. So if you were, say, producing a business report where you were removing values and you just had a whole year of things missing because nothing met the criteria there, that could be pretty confusing for people. So how are we going to solve this problem? Well, there was actually a new collector that was added in Java 9 called filtering that we can use here to solve this problem. So when we have a grouping by collector, that's really syntactic sugar for a grouping by collector that's delegating to a downstream collector called toList. So it groups the elements by the year and then hands them off to this other collector to build up the values within the year. OK. So the filtering collector will take us a little predicate as an argument. So take the expense, get the amount, check that's over 1,000, and then it'll hand it off to its own downstream collector. And what we see now is it's filtered out the low-value expenses that I don't really want to care about, but it's kept the 2015 year in as well. So it's not going to cause confusion in our reports for people going, what happened to 2015? Okay. So again, another little improvement there. The other new collector that was added in Java 9 is flat mapping. Now, in order to understand why we want to use flat mapping, we might want to understand why we want to use flat map. So if I take these purchases here, each of them had some tags associated with it. So food, entertainment, travel, utilities, either good things or bad things. Let's try and see what we were spending, what the different tags were for these expenses. So if I stream those elements, and if I just map each expense into the tags for that expense, and then just say collect them to a list, we'll see that we've got a few duplicates, and we've got these weird brackets in here, right? We've got food, entertainment, utility, travel, entertainment. Now, it's a positive sign for me that I see entertainment twice. That sounds like I had fun. But it might not be so good if we just want to see the tag information. Don't worry, Richard, you might say. Because we're putting it into a list, right? Set. So if we add things to a set, that will remove the duplicates. Unfortunately, it's changed the order of these elements here, but it hasn't removed the duplicates. Why is that? It's because the getTags method is returning a list of tags. We had many tags for one expense. So it's removing the duplicates, but the duplicates are within lists, so you don't see them anywhere. And that's why I also have these weird square brackets within square brackets. We're trying to write Java code here, not Lisp. So how do we solve this problem? Well, flat map is your friend. As ever, if you get stuck on map issues, the question you want to ask yourself, can flat map help me? The answer is often yes. So flat map is a one-to-many mapping that will then flatten in the results into the stream. So you move from one element to a stream of elements. That's why I'm getting a stream out for the tags here. And now, because we stream those elements in together, it can remove the duplicates when we do toSet at the end, and we don't have brackets within brackets that we didn't want. All right. That was flat map. What about flat mapping? Well, let's rewrite the end of this code here. We're going to collect it. And again, we're going to do a grouping by operation, taking the year of the expense, because we want our annual reporting. That's a pretty common thing that people do. And downstream, we could have used a mapping collector. So that would be a way of applying a map within a collect. So we've got a mapping collector here. So we could say, take the expense, get the tags out, and then it needs a downstream collector as well. OK? So again, we've got the problem here of having lists within sets here, brackets within brackets within brackets, the same nightmare scenario as before. We don't want our code looking like this, or output. Flat mapping is a bit like flat map, but you can use it as a downstream collector here. So you can stream those elements together. And there we go. We have our nice report. In 2016, I spent money on entertainment, food, and utilities. In 2015, it was just entertainment and travel. So it genuinely tells us 2015 was a great year, 2016 wasn't. OK? Cool. So we talked about collectors. Let's talk a little bit about the optional API as well, shall we? So at the beginning, we had that example of looking up values from properties and finding the first one that matched. Let's suppose we take that same problem, but we advance our problem domain a little bit more. So as opposed to just using raw strings, which are a bit icky, we're going to introduce a setting domain class. OK, so our setting domain class has a method called lookup setting by name. So I could say lookup user.home. And it returns me an optional with the setting in. So an optional where the value of the setting is my home directory. And suppose I looked up another setting by name, say app home, which is a missing property here because I've not set it. I get an optional.empty. So these optionals were another feature that was introduced in Java 8. So Java 8 and above users, optional thumbs up, optional thumbs down. OK, a lot of meh on optional, a lot of people in the middle on the optional. Fair enough, fair enough. So optional becomes a little bit better with Java 9. So if you were optional thumbs up, your thumb's going to be raised even higher in future. What the optional here is modeling is the idea that values could be present or absent. So if optional is empty, that means it's an empty box. If it's an optional with a value, that means you've got a box with a value in. And the idea of optional is you only use these higher-level operations like map and filter and or else and things like that to compose your optional computations, or your computations on optional values. So how does that fit with our streams example? Well, let's take our stream and, again, create it with our app home and our backup user.home. And what I'm going to do is I'm going to map those elements into a setting object by using the lookup setting by name method. Now I've got a stream of optional of settings, which is a lot of generics, which is not great. So what we want to do is we want to remove the optionals. Okay, we want to unbox the optionals, and we only want to unbox the optionals that actually have a value in the box. We want to throw away the things that don't. So a kind of Java 8 way of idiom for doing this would be that we filter these optionals, calling the IsPresent method. Then we map each optional on its get method, and then we can do our find first at the end. OK? So who's a fan of this code? Who hates this code? A lot of hatred. I can feel the rage inside you. Who's like, this is kind of OK, but not the end, but I want to do something a bit better? Excellent, excellent. Balance of emotions. So to me, this is a bit of an anti-pattern that we can see going on here. And it's an anti-pattern because it's got a combination of two optional methods that you don't want to use together. Okay? You've got optional.isPresent, and you've got optional.get. Okay? And those kind of combinations of things are a bit of an anti-pattern, because the idea with optional is it's giving you facilities to use to model operations on it, like map or else or things like that. IsPresent and get is basically the same thing as saying, is it not null? OK, I'll just use it then. It's not really advanced the situation over regular nullable values particularly. It's a bit more descriptive because it's got the optional type, but it's not perfect. Now, in Java 9, there's a slightly nicer way of writing this same bit of code. So we're going to stream those elements. And again, I'm going to map them into an optional setting here. But at this point, I'm doing something a bit weird. I'm going to do flat map, and then I'm going to method reference the optional.stream method, and then do a find first. OK, same results, slightly shorter, slightly more idiomatic. So what's happened here? Well, there was a stream method added to the optional class in Java 9. And so what that basically does is it says, look, if it's an optional with a value in, give me a stream of just that one element. If it's an empty optional, give me an empty stream. This is a one-to-one mapping between those things. So flat map takes a function that goes from an element to 0, 1, or many elements that has to be represented as a stream. So if we flat map over the optional stream method, we remove the optional boxes within our stream, and at the same time, we do it in a safe way. We filter out the optionals that are empty, because they'll be empty streams and they'll be removed. So this is the idiomatic way going forward of getting optionals and streams to interact together. If you've got a stream of optionals, you're going to see a flat map of optional : : stream. Bit unfamiliar, a bit weird at first, but you get used to it. I love it already. I love it. OK, so what else do we need to talk about? If present or else. So I don't know about people in the audience, but I go traveling from time to time. And when you go traveling, you've got to have that stage where you do your check-in. And everyone hates waiting in queues. I mean, in Britain, we love waiting in queues. But everywhere where people are sensible, they hate waiting in queues. So you don't want to wait at the queue at the airport, so you can do your online checking. So I've got, say, a hypothetical booking reference here from London City Airport to Arlanda to fly over. And I've got some software here. I've got a little booking class that will let me look up a booking using this booking reference. So if I'm trying to fly from City to Arlanda, it's got a flight, it's got my booking for me. If my booking reference was, say, from Cardiff, Wales Airport to Arlanda, and I tried to look up the booking, it would be an empty booking, because Cardiff, Wales Airport's a bit useless. Having lived in Cardiff, it's not a great airport. So that's the first step in my software. I've looked up the booking that I want to do something with, and in order for the user to interact with it, I need to have some really, really fancy UI that's going to do a couple of operations. So if the user's there, if we have this booking object and we can do something with it, I want to display a check-in page for the user to deal with it. And if not, I want to just tell them, look, there's a missing booking page. All right. So if I look up, let's change that booking back to London City to begin with. So if I look up that booking, and then I want to say, display the check-in page with Java 8, that is very easy. There's this IfPresent method that takes a callback that says, look, if there's a value in the optional, call this function, otherwise don't. So display the check-in page. Lovely. Checking in from City to Arlanda. Is that not amazing 21st century UI? Don't answer that question. But I've still got a problem here, because I've got the other case, the case of the missing booking page, which is not just a missing booking, it's now a missing page in the UI as well, because there's no way of me displaying it with the IfPresent. And in fact, with Java 8, I'd probably have to go back to the really ugly pattern of doing the isPresent in an if condition, then doing the get to pull the value out, and then having an else block. Basically, pointless use of optional. We could have just used null. So how can we improve this? Well, there's an IfPresent or else method added in Java 9. As you probably kind of got, if there was a problem here, it's going to be fixed in Java 9. That's the theme of the talk. And I can call, that takes two callbacks. So the first one is a callback to display the check-in page if it's a value present. And the other callback is the or else case. So take our UI, display the missing booking page. So if I run that code and I've got a booking, it'll tell me it's time to check in. If I switch back to Cardiff, flying from Cardiff where there was a missing booking, it tells me there's a missing booking. Okay? So again, another refinement on the optional class, slightly more idiomatic usage. Awesome. And let's look at one more improvement that we have with the optional API in Java 9. So suppose I've got a few companies, and I want to send them some information. I want to send them either an invoice by paper, snail mail, or some advertising material. I need to know what their address is. I need to know where they are so I can send them that information. And there's a few different scenarios you might think of here. Maybe they're a client of mine directly, and I've got the specific address where I know they are, or I know where my contact is, and I want to directly use my own address book. Maybe they are a company who exists in the real world, but they're not a client yet, and I need to look up the phone book, or like a Yellow Pages or something like that, like a directory services. Or maybe it's a typo somewhere, and they don't really exist, or it's just a mistake. So there are 3 scenarios here. I know their address in my database. There's another source of information where they are, but they still exist, or they just don't exist. So let's have a company name here. And for demo's sake, the company's name is going to be a client. Anonymized names. And I've got my find client function that takes the company name and returns me an optional, unsurprisingly, because it's an optional demo. So we take the find client on the company's name, and they're based in London. OK. And if we have, say, the company would be another company that's not a client, and we try and find the company, we get an optional empty because another company is not a client. Look up company details. We'll look up our phone book information. And it turns out that this anonymized other company is based in Cambridge in the UK. So we've got a couple of different optional values here. So how do we compose together these things to find, to look up these different things and find the correct result? Well, what you might feel like doing is, say, calling find client. And then there's a nice method in Java 8 called or-else-get. And that means if the optional, either return the optional value, or if it's empty, call this other function and look up a value inside there. So let's see how that works if we try that. Error. Incompatible types. Bad return type in lambda expression. Optional of client cannot be converted to client. OK, that's how you have to read out all compiler error messages. That's what Alexa will do eventually for you. So what's the problem here? Well, it's saying the return type should be a client because find client, if I unbox the optional, just has a client. And look up company details is returning an option of client, so this just won't work. It's only or else get is only for a scenario where the second function that you're calling definitely succeeds and returns the same value as is in your optional box. It's a guaranteed substitution. In practice, you often have these scenarios like looking up the company details. Like if that company's name is just like ZZZZZ, or someone's fallen asleep on the keyboard while entering information, that has to be an empty optional. It has to be a missing value. Thankfully, there's this really snippily named method in Java 9 called OR. OK? And OR is like or else get, but the thing will return an optional, and it'll just return that straight optional. OK? So if my company was a client, and I ran this code, we would get the address in London. If it was another company, we ran the code, we would get the address in Cambridge. And if someone's fallen asleep at the wheel, we get optional.empty. So we can model all these 3 cases, and we get all the values there that we have. OK? So in summary, Java 9 has this kind of really, really big, exciting for some people, dangerous for other people feature, modularity. But it's also got hosts of other features around, lots of library improvements, the read-eval print loop, really nice for experimenting with things, and potentially can be used for things like debugging applications, attach it in and do stuff like that. All these features individually are nothing to get excited about. But I think what they add up to is a much, much nicer development experience, a much more pleasant Java ecosystem for everyone. And hopefully, that trend will continue in future Java releases as well. Now, if anyone was interested in looking at the sample code that I've used during this talk, you can go to iteratorlearning.com, and you can see the Java articles. And these link through to a GitHub project from there that has all the sample code in that I talked about today on the Iterator Learning Examples GitHub project. And if you ever happen to be interested in running a training course, getting your team up to speed with Java 8, or looking at the new advances in reactive and asynchronous Java, come and talk to me, or come and talk to us, or email us about it afterwards. Thank you very much.